Hi everyone! Today we're going to learn about some special kinds of right triangles. And if we have these special right triangles, there are some shortcuts or some ratios that you can use to help you solve for the missing sides of a right triangle. Okay, so since we have ratios, guess what we're going to be doing? When you have a ratio equal to a ratio, that means when you solve, you have to cross multiply. So if you like to cross multiply, maybe solving using these special ratios will be your thing. Now, since we are solving with right triangles, what is something else that I've taught you that you can use to help you solve for either missing sides or angles in a right triangle? Absolutely, you guys, that would be sine, cosine, and tangent. So technically, in all the problems I'm about to show you, you can solve for the sides of these triangles using sine, cosine, and tangent still. So I am going to show you some alternative ways with these special kinds of right triangles that you can solve. But if you do not like them after I get done, then you can simply just use sine, cosine, and tangent to solve. So I'm basically giving you guys another option to help you solve if you have these special kinds of right triangles. It does not work with every single kind of right triangle, so you have to be careful. Okay, so our first kind of special right triangle is called a 45-45-90 triangle. And if you look at the picture, you probably already found out why I call it a 45-45-90 triangle. Okay, if you have an isosceles right triangle, which how I know it's isosceles is because I have two congruent sides. If you have two congruent sides in a right triangle, guess what? The two other angles have to be 45 and 45. If you remember in isosceles triangles, the base angles, or the two sides directly across from the congruent sides, are congruent. So if you remember, all the angles in a triangle add up to be 180. So if one of the angles is 90, 180 minus 90 is 90. And if these two angles have to be the same, well, 90 divided by 2 is 45. Guys, so if you ever have an isosceles right triangle, you have to have two angles that are 45 degrees and one angle that is 90 degrees. So keep that in mind. Guys, so if you have a 45-45-90 triangle, there will be some special ratios that come into play that can help you solve for the missing sides of your triangle. Now, like I said earlier, if you hate using these special techniques to solve, you can always fall back on sine, cosine, tangent. Okay, and there's actually three ways you can solve it. So anyways, before we talk about that, in isosceles right triangles, so remember two sides are congruent and the base angles are congruent. Okay, so the base angles are both 90 degrees and one angle is 90 degrees. So 45, 45, 90. Now I'm going to give you two methods to help you solve. Technically, there are three methods. The first method to help you solve, well, if you have a right triangle, you can use Pythagorean theorem because in isosceles right triangle, two of the sides are congruent. So if you have a value for at least two of the sides, you can solve with Pythagorean theorem, which you'll be able to use. Remember, when you only know one side of your right triangle, you can't always use the Pythagorean theorem. That's why in the other triangles we use sine, cosine, tangent. But in 45, 45, 90, you can solve by Pythagorean theorem. You can also solve by using these special ratios. So, if you remember, on a right triangle, the legs are the two sides that make up the right angle. Okay, so if you use the ratio 1 over the leg, it doesn't matter which one you pick since they're congruent, that will equal root 2 over the hypotenuse. H is the hypotenuse. Okay, so you can use these two methods. Also, like I said earlier, you can just use sine, cosine, and tangent as well. So technically, there are three methods for solving. Okay, the two congruent sides will be called our legs in the 45-45-90 triangle ratio formula, and the hypotenuse is the h. So the L in the formula is the leg, the h is the hypotenuse. Okay, so using both of these methods, I'm going to show you how you can solve for the sides of a 45-45-90 triangle by either using the Pythagorean theorem or nifty ratio 1 over leg equals root 2 over the hypotenuse. Also, in example 1, I will show you that doing sine, cosine, and tangent will also give you the same answer. So that will be pretty cool. All right, well, let's get started on example 1, you guys. I'm already so pumped up. Let's do it. Okay, so example 1. Let's see if this will work. Please work. Please, please, please. Okay, sorry guys, I think I'm going to have to reopen it. It's frozen for some reason. Sorry. Please work this time. Sorry for the delay, you guys. I think the demon cats have gotten my document camera. Here we go. Okay. Now let's start solving example 1. So I'm going to show you how to solve for the missing sides of the right triangle. So we will be finding all the sides of the right triangle in a 45, 45, 90 triangle, which is an isosceles right triangle. So I'm going to show you how to solve using the Pythagorean theorem and also using these ratios, and I'll show you that you get the same answer. In this problem only, I'll also show you how using sine, cosine, and tangent will give you the same thing. Okay, well, let's get started. So the Pythagorean theorem, we got our a squared plus b squared equals c squared. Okay, so remember the a and the b are the two sides that make up the right angle of your right triangle, which in this case it doesn't matter which one you pick since they're congruent. And c is the hypotenuse, which is the side directly across from the right angle, which that would be our 8. Okay, so I'm going to set this up using the Pythagorean theorem. So I'm going to have the a squared and the b squared. It doesn't matter which one you make the a and the b. I'm going to call this side the a and this side the b. And the side directly across from the right angle is the hypotenuse, which in the Pythagorean theorem is the c. Alright, so a is going to be x. So we have x squared plus b squared, which is x squared, equals c squared, which c is 8. Alright, let's start solving. So don't forget, you guys, when we add variables, remember, we don't touch the exponents. Leave them alone or the demon cats will get you. Okay, we're going to simply add the numbers in front of the variables, okay, which I don't see any numbers, which means there are secretly 1s in front of my variables. Okay, so I'm going to add the 1 and the 1. 1 plus 1 is 2. So this will be 2. Then I'm just going to bring on down that x squared. And that will equal 8 squared. 8 times 8 is 64. Okay, and then from here, you simply just solve for x. Okay, so currently the 2 and the x are secretly multiplying together. So the way that I move 2 to the other side is by dividing both sides by 2. So 2 divided by 2 will cancel and turn to 1. So we're left with x squared equals 64 over 2. Well, that will give me 32. Alright, and then from here, what is the inverse of a square? How do we undo or cancel out a square? Holy to the hot dog. We do square root both sides of the equation. Okay, which the square root and the squared will cancel out, so I'm left with x equals, don't forget when you square root both sides of an equation, a plus or minus will appear. Plus or minus the square root of 32. Alright, now, we're not done yet because is 32 a perfect square? No, it is not. So how do we solve when we have a radical that is not a perfect square? We do need to make a factor tree and break it on down. So let's break it on down. Alright, let's figure out what goes into 32. So I'm going to set up my answer to this problem. Okay. So we have 32, well, it breaks down into lots of things. I'm going to say 8 and 4. 8 breaks down into 2 and 4. And 4 breaks down into 2 and 2. Alright, let's start circling those cute little couples. Remember, for every couple that you circle, they get to leave the house to go on their math date. So I got one pair of 2s. I got another pair of 2s. And remember, for each pair, only one will come outside, and if you have more than one, you multiply. So it'll be 2 times 2 for each pair. And then my lonely single 2 has to stay in for the night, stays in the square root. Okay, so this will be x equals plus or minus 4 root 2. Now don't forget, you guys, since we're talking about the sides of a right triangle, which one of my answers doesn't make sense? The positive 4 root 2 or the negative 4 root 2? Okay, you can't really have a negative side of a right triangle, so the only answer in this case that will make sense is the positive 4 root 2. So x will be 4 root 2. Okay, and those are the two missing sides of my right triangle, the two x's. So x is simply 4 root 2. Okay, now I'm going to show you how to solve this using the ratio technique. So if you have a 45, 45, 90 right triangle, okay, then you can use this nifty proportion to help you solve for the missing sides of your right triangle. Okay, so I'm going to solve now using the 1 over leg equals root 2 over the hypotenuse. Okay, my two legs are the two sides that make up the right angle, which are these two sides right here. I'll circle them to differentiate them from the Pythagorean theorem A, B, and C. Okay, the hypotenuse is the side directly across from the right angle. So this is the hypotenuse. All right, well, let's set up our ratio. So we have 1 over the leg. The leg is x, and that will equal root 2 over the hypotenuse, which the hypotenuse is 8. And now that I have a ratio equal to another ratio, how do I solve? I would, in fact, cross multiply, so let's do it. Okay, so x times root 2, well, that will be x root 2 or root 2x, whatever floats your boat. All right, and that will equal the other direction, which is 1 times 8, which is 8. And from here, I simply have to solve for x. Okay, so the root 2 and the x are secretly multiplying to each other right here. So the way that you move the root 2 to the other side is by dividing it on both sides. Okay, root 2 divided by root 2 will cancel out, turn to 1. So we're left with x equals 8 over root 2. Now, you're probably looking at this answer and you're probably like, Miss Long, this answer is not the same as what I got when I solved using the Pythagorean theorem. Well, that's because our answer is not in its most simplified form. Okay, typically we do not leave radicals in the denominator of a fraction because if you see, it usually is not in its most simplified form. Now, technically, you guys, these two are the same exact answer. Okay, like if I pull out my calculator, if I type in both of those answers, they are the same thing. So let me pull out my calculator. Come on, calculator. Let's see. There it is. Okay. Let me see if I can do this a little better. Okay, here's my calculator. Sorry about that. Okay, so if I type 4 square root, which the square root is right above the x squared key, so I'm going to hit second x squared. 4 root 2, if I hit equals, it's about 5.666. Okay, if I do 8 divided by the square root of 2, oops. Sorry guys, I messed it up. Okay, 8 divided by square root 2. Okay, here you go. If you see, you get the same answer, okay? But it's always good to write our answer in its most simplified form, okay? So we need to deal with this radical in the denominator. And how we deal with this radical is by doing something called rationalizing the denominator, which is where we eliminate the square root in the denominator. Okay, so how we're going to do that, we need to think about, well, what is the inverse of a square root? What is the opposite of a square root? Well, the opposite of a square root is to square. Okay, so if I were to square the square root, the radical would go away. Okay, so basically what I'm going to do, you guys, whenever you square a number, you multiply a number to itself. Okay, so if I multiply root 2 to root 2, it should cancel out the square root, which I'll show you what will happen. Okay, so now, if I ever multiply something to the bottom of a fraction, it will change the value of the number, and I don't want to do that. So if I multiply it to the bottom, we also have to multiply it to the top. And the reason why anything divided by itself is 1. So essentially, it's like I'm multiplying 1 to my fraction. Okay, so when we're rationalizing it, we're essentially squaring the square root, and that will cause the square root to go away, but if we do it to the bottom, we have to do it to the top. Alright, so let's see what happens when we multiply by root 2 and root 2. Let's see. So we get x equals 8 times the square root of 2, which is 8 root 2, over, whenever you guys multiply square roots together, okay, you multiply them underneath the square root. So root 2 times root 2 is like the square root of 2 times 2. Alright, which this equals 8 over root 2, and 8 root 2 over 2 times 2 is 4. And what's the square root of 4? Holy hot dog, it is 2. So if you guys see, by multiplying the denominator by a square root, multiplying it to itself, it makes the square root disappear. So whenever you end up with a square root in your answer, you will have to rationalize the denominator to make the square root go away. So I have 2, and then in the numerator I have 8 root 2. Alright, and then to get your final answer, okay, you cannot divide numbers that don't have a square root to numbers that have a square root. So the only two numbers I can simplify down are the two numbers that don't have a square root, which 8 divided by 2 will give us a 4. And then look at that, you guys, we end up with the same thing. So if you guys see, I got the same thing here and here. Pretty cool, right? Now, one last thing. I was going to tell you in example 1, also you can solve this using sine, cosine, and tangent. Okay, it will give you the same thing. And I'm just going to only show you this in example 1. So, it doesn't matter which angle I start from. I'll just show you over here. Okay, let's say we start from this angle. Alright, and it doesn't matter which x I use because they're the same thing. So, I'm just going to use this x, which this is the opposite side because it's the side directly across. And then this is the hypotenuse, which is the 8. So, if you remember, sine uses opposite and hypotenuse. So, if I say sine of 45 degrees, that will equal x over 8. And then when I cross multiply, we'll get x equals 8 sine of 45 degrees. And if you guys see, when I type that into my calculator, I should get the same thing. So I'm going to pull out my calculator real quickly. Alright, so I'm going to type in 8 sine of 45. And if you guys see, I get the same thing. So you guys have 3 options for solving for the sides of a 45, 45, 90 degree right triangle, which is pretty cool. Alright, so using all that, let's get going on example 2.